Okay, this question is a little bit different because we're given a little bit harder function up here, e to the power of x plus e to the power of minus x. Now again, like most area questions, what we need to do is work out what the graphic actually looks like. So if I actually draw this up, and they're actually around the way, that should be e to the power of minus x there, and that's e to the power of x. So if we draw up those, and then look at adding all our y values, what will happen? So when I look at the critical value, where x is equal to 0, they both go through 1, so it must go through 2 there. So it must be 0, 2, because they both 1 at the same when x is equal to 0. But then what we notice is when x approaches negative infinity, e to the power of x approaches 0. So it's becoming almost nothing. And e to the minus x approaches infinity. So really what we're going to do is just add on a little bit to these curves every time. And so the curve will just be inside. The same thing happens over this way. Like e to the power of minus x approaches 0, while e to the power of x approaches infinity. So again, this is going to add on just a little bit to e to the power of x. So that's why it gets closer and closer to the curves. And it basically looks like e to the power of x there, e to the power of minus x. So that's what our sketch looks like. What we want is find the area between minus 1 there and 1 there. So the area in here and in here. So what you start to look at and go, well, hopefully you recognize that it is symmetrical. It's an even curve. So what I can do is use a little bit of notation and go, well, my area here would be two lots of the area between 0 and 1. Instead of minus 1 to 1, because it's symmetrical, I'm going two lots of 0 to 1 of e to the power of x plus e to the power of minus x dx. So let's start integrating that, which is not a hard integral. I'll leave my 2 out the front and gives me e to the x minus e to the minus x as my integration. So it's not, as I said, not a hard integration. And that would give me 2 lots of, and now e to the power of 1 minus e to the power of minus 1. And we get here e to the power of 0 minus e to the power of 0, which are going to cancel each other out because it's exactly the same. So that's giving me 2 lots of e minus 1 on e unit squared. So there's my area for that. 2 lots of 0 to 1 of the function, and integrates down to give me that expression there, or that value there. We want to find the volume. The volume is going to work very similar. It's going to have pi y squared dx between minus 1 and 1. Y is x plus e to the minus x. So again, I'm going to go 2 pi and 0 to 1 because it's symmetrical. Even the volume will be symmetrical there. And then I can't do any other rule except expand this out. So how do I get that? Well, the trick is that e to the power of x plus e to the power of minus x, we multiply it by itself. We've just got to take a lot of care. E to the x times e to the x is e to the x. E to the power of x times e to the power of x minus x. We're going to add the powers, which is x minus x, which gives us 1. E to the power of 0. E to the power of minus x times e to the x. Again, add the powers. Gives you e to the power of 0, which is 1. And then e to the power of x times e to the power of minus x would be e to the power of minus 2x. I left my 2x off there. So there's how I get down to the 2. 1 plus 1 is 2. And there's my expression that I need to integrate. Integrate e to the 2x becomes a half e to the 2x. E to the minus 2x integrates to minus a half e to the minus 2x. 2 integrates to 2x. Don't forget to integrate the 2. So between 0 and 1, we substitute 1 in. We substitute 0 in. Which again, you're going to see half e to the 0 minus half e to the 0. It's going to cancel each other out. Plus 0. We're just left with what's inside there. Half e to the 2 minus half e to the minus 2 plus 2. And expand and multiply the 2 through, gives us cancellation there, and 4. And there's our answer as we're going to leave it. We don't have to do anything else with it.